In this video there are three types of problems that we are going to discuss. Two of them are going to be angle-angle similarity type problems, and the third one is just sort of a corollary of those that are called railroad track problems. And while technically they aren't triangle problems, I'll show you how they actually could be if we extended some lines and looked at it a little bit different. In the first four problems, I'm going to ask you guys to write a similarity statement and state why triangles are similar. That's what we did the first day after our second quiz. That's where we have to state two congruent angles. In this case, we have parallel lines. Angle R is congruent to angle L. And angle Y is congruent to angle I. So we have to defend why these angles are, if IL and RY are my parallel lines, which was given, I don't have to state it, then these angles are alternate interior angles. So alternate interior angles of parallel lines are congruent. Now I have two angle congruent statements. I can state that my triangles are similar. I'm going to name the first triangle, and it does not matter which way I name it. Triangle RYE is what I'll do. It is similar to triangle. It does matter how I name the second. Just like with the overlapping triangles yesterday, make sure you match up your corresponding congruent angles. R is congruent to L, so I started with R, I start with L. Y is congruent to I. Screwed that up. There we go. And then we end with E. By angle-angle similarity. So all I've done now is I've written a similarity statement and defended Y. Now I have to solve for X. These are tricky because these are rotation similarity. They're rotational similarity. So I like to look at it by writing all of my congruent or my proportional corresponding sides first. Meaning I'm not going to look at the picture. I'm going to look at this statement and see that RY, segment RY, corresponds to segment LI. That segment YE corresponds to segment IE. And that segment RE corresponds to segment LE. That's the way I know, that way I know exactly how to set up all of my fractions. I know that segment RY is 15. That segment LI is Y. Segment YE is 10. Segment IE, I to E is 5. Segment RE, R to E is X. And segment LE is 4. So my ratios, in fact, my similarity ratios, spell that correct, would look like this: 15 over Y, 10 over 5, X over 4. I have to solve for X. Obviously, 15 over Y won't help me solve for X. These are the two that will. So I set them equal to each other, cross multiply, 5x equals 40, and x equals 8. Scale factor, don't forget, if these are my similarity ratios, scale factor is the reciprocal. So I already have it. My similarity ratios are 10 over 5, which is the same as 1 over 2. X is 8, so I could have used 8 over 4, but 8 over 4 is the same as 1 over 2. That's my similarity ratio. My scale factor is 2 over 1. Number 2 is a very similar type of problem. What I want you to do is hit pause and start by doing the first part. Write a similarity statement and state why the triangles are similar. Based on the parallel lines and the alternate interior angles, I have a triangle BLA similar to triangle EKA by angle-angle similarity. Make sure that whatever you have it named, B and E are in the same location, L and K are in the same location, A and A are in the same location, first, second, or third. If you haven't already done so, press pause and write the 3 fractions, just using your side lengths that are corresponding. So our 3 fractions should be BL over EK, which is x plus 8 over x, LA over KA. I don't know LA, so I can't use it. Obviously, that's the fraction we're not going to use. So I need to set up the proportion x plus 8 over x equals 9 over x minus 1. These are one of the harder ones. When we cross multiply this on the first diagonal, this multiplication, it is x plus 8 times the quantity of x minus 1. And that's going to equal 9x. This is that 4-letter F word. First, outside really is just distributive property. I'm distributing x. X times x is x squared. X times minus 1 is minus x. Distribute the 8. It's plus 8x minus 8 equals 9x. I combine my like terms. X squared plus 7x minus 8 equals 9x. Scroll down a little. Do we have room? X squared and x in the same equation. Make it equal 0. Subtract 9x. I'm going through it very methodically, one step at a time. Now my factors. X squared is x times x. I fill the rest in with what multiplies to negative 8, but at the same time adds to give me negative 2, constant coefficient of x. Hopefully we see negative 4 and 2, so it's x minus 4 and x plus 2. Those are your factors. Zero product property says x minus 4 is 0 or x plus 2 is 0. X is 4 or negative 2. I can just look up here and see. It's not negative 2 because negative x is a side length and my side can't be negative 2. X is 4. Scale factor, once again, these are my scale factors. But if my scale factor or my similarity ratio is 9 over x minus 1 and x is not this but 4, it's 9 over 3, which is 3 over 1. My scale factor is the reciprocal, 1 over 3. The second video is going to go over our overlapping triangles that do look different than the ones from yesterday. Go ahead, back to Canvas to watch the second video.